In this problem, we yet once again have conversions and percentages. And we're going to be focusing a lot on this problem on converting from the metric system to the English system, or from the English system to the metric system. So the problem reads as such. Copper can be drawn into thin wires. Now, the shape of a wire is going to be a cylinder, so you got to keep that in mind. And then the volume of a cylinder is going to be pi r squared times the height, or the length of that wire. How many meters of a 34 gauge wire whose diameter is 6.304 times 10 to the minus 3, so that's the diameter, we're going to need to convert that into the radius, can be produced from copper in 5.01 pounds of covellite? So we have the 5.01 pounds of covellite. Now, covellite happens to be a mineral that contains copper. And so that can be produced from 5.01 pounds of covellite. It's an ore of copper that is 66% copper by mass. Now, the density of copper is going to be 8.95 grams per cubic centimeter. Now, this is going to be our covellite, and we know that 66% of this is going to be copper. So if we take the mass of covellite times our percent, that's going to give us, the mass, or the pounds of copper. So that's going to be 3.3066 pounds of copper. Now we want to get this out of the English system into the metric system, because it's a little bit easier to work in that system. And so I'll use a different marker for that, just to kind of highlight how to do that. You should know how to do that. So this is 3.3066 pounds. Convert that, or make that into a fraction. We know that for every kilogram, there is 2.2 pounds. Now, it'd be a whole lot better if we could just put this in terms of grams, and so we can simply multiply by 1,000. So 1 kilogram is equal to 1,000 grams, and that's going to be equal to 1,503 grams of copper. So if we have a little over 5 pounds of covellite, from that what can be smelted is going to be 1,503 grams of copper. And we're just going to hold on to that. And we know that the density of copper is 8.95 grams per cubic centimeter. And this is going to be mass over volume. Now we can solve this for volume. So our volume is going to be equal to our mass divided by our density. We know that the mass is 1,503 grams of copper. We know that the density is 8.95 grams per cubic centimeter. From this, we're going to get the volume. So the volume of that wire, we go through and do this arithmetic, and we get 168 cubic centimeters is going to be the volume of this hunk of copper. Now, we're given in the problem that the diameter is equal to 6.304 times 10 to the minus 3 of an inch. That tells us that if we divide this by 2, we find out that the radius is going to be 3.152 times 10 to the negative 3 inches. That's going to be our radius. Now we can convert this into the metric system very simply by remembering that for every 1 inch, it's equal to 2.54 centimeters, which is going to be equal to 8.01 times 10 to the minus 3 of a centimeter. All right, we're almost there. Hold on. The volume of a cylinder is going to be pi r squared times the height. Now the height is going to be the length. We can solve this now for height is equal to the volume divided by pi r squared. The volume we have right here, which is 168 cubic centimeters. pi is going to be 3.14. Our radius we found here, which is 8.01 times 10 to the minus 3 centimeter, and we have to square that. We do this arithmetic quickly, and what we get is we get 8.343 times 10 to the 5th centimeter. We can convert that into kilometers, just give us a little bit of a better idea. And this is going to be 8.34 kilometers is going to be the length of that wire. That's going to be approximately close to about 5 miles long. All right? If you have any questions on this problem or any other else in this chapter, please let me know.